Hey everyone. Um, I'm going to be continuing a little bit of work that Tim and I started last Wednesday, where we were building out a custom MCP server implementation for the Effect AI packages. I did a little bit of work off stream, and when we left off the last stream, Tim and I had built up enough of a transport layer for the MCP server based on the spec, which I can actually pull up. Let me pull up the spec. I think we had built up enough of a transport layer to make this like somewhat workable. And then I actually hacked it together enough to connect to the MCP inspector, which is, I'll just leave it here. It's not running currently, but I had gotten it enough of the way there to actually be able to receive requests from the client and respond, and then to allow like pinging between the client and server. But I wasn't really satisfied with the protocol or really any of the work that we had done, just because it didn't feel like a clean solution. We already have a lot of this logic built into Effect RPC. So I kind of wanted to lean even more into the RPC stuff for the actual runtime. So I started just refactoring a little bit of the, I think we had called it MCP protocol last time, or protocol, forget. But I started refactoring it a little bit into an interface called MCP transport. And this thing is basically the thing that allows you to send and receive messages. So this interface is represents a transport can and receive messages. And right now, this is extremely specific to the server, because you see when we actually run the transport, we get messages from the client, and we send messages from the server. But once we get the server to a good enough place, I'll make this a little more generic, and then we can maybe reuse this also for client messages. And the goal of the transport is really to take receive encoded messages after the transport is run and allow you to do something with it, and then to send encoded messages from wherever, in this case the server, to the client. And then there's a method here from called end. I'm not sure if we'll need it. We might, just for like notifications, but and then I refactored the whole. I think we had the concept of like a session ID here, because the MCP spec mentions, if you look at the life cycle, I think it mentions that they support where is it? Somewhere in here. Maybe it was in transports. Session ID. Yeah. So we had originally thought that all messages would have a session ID, but I realized in the spec it very plainly says that streamable HTTP may assign a session ID, but it doesn't have to be there. So we still need we needed a way to identify client connections that were coming in so we can manage them. That didn't rely on the session ID. So I actually reverted the transport back to just using the same implementation. If you look at like any of the RPC code, we just rely on like a client identifier that we generate to identify the client. And then I refactored the constructor for the standard IO transport for the MCP implementation a tiny bit. Basically, I just made it a little bit cleaner so that when we so this on data function is what we bind to the standard input data event. So whenever we receive any data, we use whatever RPC serialization. In this case, I'm just like hard coding the ND-JSON serialization to the transport, because none of the other ones are really what we want to use. So we parse out the data using the new line delimited JSON, since MCP uses JSON RPC, which is sent over the wire as new line delimited JSON. We parse out those results, and if we have any results, then we offer them to an internal mailbox. And I cleaned this up a little bit. So if there's an ID in the message, then we know that the incoming message is a request. But if there's no ID, then we know that it's a notification. And you can see here, I've got like now, I changed the way that the client messages are kind of encoded. So when we receive, where is it? In here somewhere. Client, the client request encoded and the client notification encoded. I changed the way these look a little bit. So we scroll up to the type helpers here. Basically, like I tag them with the specific type of message that's coming in. And now I find like the actual tag of the RPC into the method field. I think previously we were using the method as the tag, but that didn't really allow us to easily differentiate. So yeah, we go back. So, and again, this is per the spec. So if we look at the protocol, so requests will always have an ID, even though JSON RPC does not require an ID, but the MCP protocol does for requests and for responses, but notifications don't need an ID because it's a one-way message. So there's no, you don't need to track like responses. So anyways, that's how I cleaned this up a little bit. And then we have an error handler, which we'll probably have to revisit at some point. We have the same finalizer, and then I have this send message function. So again, I re-encoded the way these messages are supposed to come in. So now, because of the way JSON RPC works, we can either send successful messages, failure message, not JSON RPC, the MCP protocol. We can either send successful messages, failure messages, or notifications. And so if we get a successful message, we encode it as such, where the property of the message is the result. Failures are encoded with the error property, and notifications are encoded the way that they should be as well. And actually, this should be message.method. The rest of this is pretty similar. The only other change I made is that when you send a message to the transport, you can either send a single message or a batch of messages. And that's just because I wanted to support the fact that JSON RPC technically allows you to send batches, and the spec says that we have to respect that somewhere. Batching. We must support receiving JSON RPC batches. We may support sending them. So I fake supporting sending them right now because I actually just take the array if it is one and I just send the messages one by one. But we can like revisit this later and improve it. So those were the changes I made to the transport layer to try to clean things up a little bit. And then the MCP schema just has like a bunch of like type helpers and stuff. You saw Tim and I declare one of these RPCs the last time. I think it was the maybe initialized one or so initialized. Yeah. So all of the messages and notifications are encoded as RPCs right now. We may or may not revisit this later, but for now this works. and then we can keep it like this for the moment. The point is that we want to be able to encode the payload of the message, so what the incoming like data is going to be, and then we also want to have the potential success and error types associated with like the same message. So like if you look at the way the spec is encoded for in the TypeScript encoding of this, the requests and responses are like separate, which is kind of annoying from like a type perspective, because you don't know like on a type level which requests and responses are associated with one another. But that can be useful like when you want to implement the functionality. So like if you're implementing a handler for initialize, for example, it'd be nice to be forced to provide a type safe result, whether it's a success or an error. So that's why we decided to use the RPC last time. And the reason why we're not using like schema.tagged request or something is because then the tag would actually end up in the payload. So when a tagged request is sent over the wire, the tag ends up in the payload, so that on the other side, it can be decoded properly. But we don't want that. So yeah. So I'm not going to go through like too much of the schema of the like MCP schema, but you can look at the spec if you're interested. I think what gets interesting is when we start looking at like the actual server implementation. So this is like still extremely work in progress. So don't judge the code quality. But we've got 3 services at the moment that we implement. We've got the actual server itself, which at the moment doesn't expose any methods. I think in the future it will. We've got the MCP server options, which basically at the moment I'm just putting the capabilities in here, but we could put other things in here. And then the implementation, which is really just the name and version of the MCP server. So the idea is that like all of this information is available in the environment for you to use. We got the protocol versions here, and then a constructor for the actual MCP server. So the first thing we do is we grab the transport to use. Whatever transport's in the environment is the one we're going to use. We grab the context at the point that the constructor is called, create a scope. We've got some type helpers here. A lot of this stuff I grabbed directly from RPC, like the RPC implementation, and modified it slightly for my uses. This is very likely going to change in the future, but I wanted to at least get things wired up to the point where I was before with my Hacky implementation. We've got tracking of clients here. So just a map of client ID to the actual client itself. And then you can see here in the server implementation, we're actually using the RPC servers make the constructor that does not do serialization for you. So the way this works is, the way these constructors work, this one specifically, is that you get, when you call the constructor, you pass in the RPC group that you want to use. In this case, I'm using the client RPCs, which is basically just the request RPCs from the client merged with the notification RPCs. And then you get back, if we ignore the actual implementation of this constructor for a second, you get back a server. And the server will allow you to send messages, write messages into the server that have already been decoded. So if we look at like what that looks like, at the very bottom here, we're running the transport, which like essentially starts the transport running. And this function, this function here allows us to get the client ID and the request that was sent in. So if we've already got the client, we can use it. Oh, what's up, Dylan? Hey, everybody. Probably get annoyed with my walls of text in Dylan's chat, so now you can spam my chat. Decided to implement a DNS resolver from complete scratch and not sure to use not use Node DNS because it's problematic. That's cool. We do that a lot in effect, not use. Yeah, I got you. We do that a lot in effect. You can see like I'm not using for this MCP server thing. I'm not using the official spec. I'm implementing myself. There's other reasons for that. Primarily the fact that the MCP server, the official MCP server TypeScript SDK implementation is actually like extremely tied to Zod. Like to the point where you can't override how it does. You can't override how it does like encoding and decoding. And we obviously wanted to use effect schema. So that's basically the motivation for building our own. Why would they not use standard schema? Yeah, that's actually a really good question. And there's an issue about it. So Harry Sullivan, who's in our community, standard schema. Here we go. In our community, opened this issue back in February. And basically like raised a lot of the issues that I had when I was looking through the official spec. Basically like wanted to use his own version of whatever schema. And the long and short of it is like he actually opened a PR to try to migrate to your standard schema, but ended up like, where was it? At the very end here. There he gave basically an explanation of like why this PR, he let it kind of die. But if anybody's curious, yeah, I'll post this in the chat. So anyways, that is my impetus for trying to build my own MCP server. And at the moment, we've got a very hacky version that sort of works. So we can actually look at that before I get rid of all this for a second. Why are you not happy with me? There we go. If I do... Oh, I'm not in Tmux. Shame on me. Tmux new. Dylan, I stole like everything about your setup. So, sorry, not sorry. MCP server. So we can actually run this and you guys can see what I mean. It's like super basic, but you can run, there's this like model context protocol inspector thing that they provide that you can use for debugging purposes. And you can launch it using the standard IO driver or transport just by calling the command you want to use. So if we run this, you'll see the proxy's up and running. It's on 6274. So if we reload this and we connect, please work. All right, very nice. So you can see all the messages that are sent back and forth from the client to the server. So if you look at the spec, the very first thing that the client and server do with one another is they initialize themselves to do like basically capability and version negotiation. So making sure that the spec is the same version or at least a compatible version between the client and server. And then also the client telling the server what capabilities it has and vice versa. So there's an initialized request sent, an initialized response sent back. And then again, notifications are kind of optional in the spec. We're going to try to implement them, but for now, the initialized request that was sent from the client looks like this. And then my server, my demo server that I'm running, responds and it says, oh, I can do logging, for example. And I think I also wired up pinging, so I can ping the server. You can see the client sends a ping, the server sends an empty response. But I gotta say, after like working with this spec, it's like the weirdest spec. The whole spec is strange to me, but it's cool to implement, but it's kind of strange. So if we go back to, so we were just walking through the implementation here, but if we look at running the actual transport, so we've got a server transport running here. You get a client ID, which is just a number, and then you get requests coming in. So every time a request comes in from a client, this function gets called or gets run. So we try to get the client from our list of tracked clients. If it's not there for some reason, we create the client. And again, a lot of this stuff I stole from the RPC server implementation and adopted for my own uses. So this probably won't stay the same. I just didn't know like what I would need and what I wouldn't. And then the requests, like I showed you folks before, we're creating using this from client encoded type. Let me stop the server. So when a request comes in, we create a request ID. We try to grab the schemas for this particular RPC. So like when a request comes in, we attempt to get the RPC out of our RPC group using like literally just grabbing it out of the map. And we grab the RPC based on the request method. Because again, I mentioned that like the tags are for internal use. They're for us to identify like which requests coming in are requests, which ones are notifications. And the methods though are the actual like protocol methods. So the RPCs themselves are tagged based on method. So once we get the schemas, then we can try to decode the payload using the schema. And then if it fails, right now we're not doing anything, but we need to change this to send an error. If we succeed, then we set up the schemas for this particular request. This way we can cache them and we don't have to construct them every time. And this is, I think, the interesting part. So the transport, like the server is essentially like almost like a proxy that sits in between that uses the transport to do stuff. So we write the decoded request into the server. So you see this write method takes in a client ID and messages from the client, but they're the decoded ones. So that's why we have to perform this like decode on the encoded version first. So we write that into the server. The server will use the handlers from the RPC group to generate a response. And then the response kind of just gets spit out right here, which is cool because then like the whole point of this make no serialization constructor is that everything that happens inside the server is dealing with decoded types. And then you can do encoding at the boundaries and use the transport to send the messages. I take no credit for this like architecture. Tim Smart did all of this in RPC and I'm just repurposing it for the MCP server. So this comes from the mind of Tim Smart. I think it's a really cool way to design a server with effect is that the server itself just deals with all the decoded types. And it's kind of just like a proxy that allows you to write into it. There's another method on the server that allows you to disconnect clients too, I think. Server dot. Oops. Hello? Yeah. You can disconnect clients and you can write decoded requests into the server. That's kind of cool. I think this is interesting. And yeah. So before I started the stream, what I was trying to start doing is kind of scaffolding out the rest of this on from server method. So the thing that receives decoded response. So again, we write a decoded request into the server. This thing internally uses the handlers that are in the environment for running the particular RPC. And then it spits out a response. So the response itself is a response for any of these RPCs. And then we're responsible for encoding the response and then doing something with it. The response can be one of a few different types. It can be a defect. It can be a client ending. So these are relevant to like RPC, right? Because the RPC client knows how to deal with these particular responses. We don't really need these, but because we just want to make use of this constructor, we have to do the, what's it called? The integration between the two. So we're dealing with these specific RPC response like tags, but really all we care about is the internal, like we want to encode the value that comes back and either send back the error or the success. So I think this chunk one, I mean, I'd have to ask Tim. I haven't looked too deeply into the code, but I'm pretty sure this chunk response only happens if you're doing RPC streaming. So if you have a stream RPC, I think that's when you would get chunks out. So in reality, I think we can actually ignore this if we wanted to. But for now, I implemented it. I think maybe on Wednesday, if Tim and I decide to keep streaming on MCP server stuff, I'll see if we can just ignore this. But I think the interesting ones are the exit and the defect messages. Client end will become interesting, I think. Will become more interesting when we're dealing with the streamable HTTP protocol. But I don't think right now, like, I mean, this is literally just deleting the client that we're tracking and then sending it or calling the end method on the transport. And if you look at how it's currently implemented for the standard IO transport, scroll down to end. Right now, I'm not doing anything. There's probably cleanup stuff I have to do here. The spec does outline some stuff. So if we look at the spec, like, where's it? Transports. There's like stuff you have to do. Like when we terminate the sub process, this thing is going to close standard in and terminate the sub process. We might have to do some stuff. But for now, we're not doing anything. Okay. So if we come back here and look at like when the server generates an exit response, that means that the RPC handler was called. It either succeeded with its success. So again, if we look at, maybe it's easier to grok if we like look at these things side by side. Initialize. So, and Tim can like roast me on Wednesday if I'm wrong about all this. Again, I haven't dived too deeply into the code, but this just makes sense to me. So when the initialize RPC is sent from the client to the server, right? The transport will call this function with a request of type initialize, and we'll hit this request block, right? We'll decode the payload that's coming in from the client with whatever schemas we have. If we fail, then we have to send an appropriate error message. Not doing that right now. But if we succeed, then we get the decoded payload here, which again for the initialized message would look a particular way. And so we write that decoded message into the server. And again, a lot of this stuff is currently not relevant for the standard IO transport. It might become relevant like when we're using streamable HTTP. But I think the important things here are the request ID, the request method, and the payload that we're sending into the server. So then inside the server, we go back up here. The server is going to get the handler from the effect environment that we registered for the initialize RPC, which I'll show in a second. It's going to run that handler. And in our case, we'll most likely be hitting this exit block, where the exit would either be a success with initialized result, right? A shape that looks like this, or an error with an MCP error. And so right now I'm using code that is, again, taken from like the RPC implementation, but I think that we'll probably have to modify this for our own purposes. The difference between like RPC and what we're doing with the MCP server is that the RPC server has no knowledge of like the protocol ahead of time. Like we don't know anything about what a user is going to give us in terms of a protocol, right? They can register whatever RPCs they want with whatever schemas. And we don't really know ahead of time, which is why the server, like, we have to deal with types like this. But for the MCP protocol, the protocol is known statically ahead of time. Like the protocol doesn't change unless a new version gets released, right? So we could probably clean up a lot of this like encoding and decoding stuff that we're doing, a lot of the gymnastics we're going through, and make this a little bit better. But for now, I wanted to like, again, get to the point where we are at least running something that is working. So if we hit this exit block, we're dealing with an exit where we either have a success of initialized result or an error of MCP error. So this handle encode function is not doing too much under the hood. I'll show it in a second, but we essentially pass in the client we want to use, the request ID, the effect that's going to do the encoding, right? So we're encoding the exit value here, giving it the appropriate context. And then we get an encoded exit out, which unfortunately, because it's an encoded exit, I can't use exit.match because the exit symbol and everything that we need is not there. So I just have to match on the tag. If we have a successful exit, we return with the success value. And if we fail, I still have to implement like the failure types. So one thing that I was trying to figure out is right now, I lose track of the method with the code the way it's written right now. So for example, if we call like the initialize request, I lose track of the method entirely. Once the request enters the server, the response again is not the structure of the response itself is not something we control. And what I mean by that is like these different tags, we don't control these unless we go make changes to the RPC module, which I don't really want to do. So, we need to find a way to get the method out of like to be able to respond with the appropriate method. So in this case, ideally, if we're running the initialize request, we ideally want to respond with initialize here. One thing we could do is, because we're trying to cache the schemas as heavily as we can, we could just add a property to the client schemas. I think that'll probably be the easiest thing to do for now. So we'll probably do that. But the last thing I'll just show is this handle encode method. It's not doing anything fancy. It's literally just running this encode effect. So this is the thing that's going to, should rename this to like encode result, maybe, or encode. It's going to run this encode effect. And then with whatever value we get back, we're going to use the transport to send that value. So this onSuccess function really needs to return a server encoded or read only array. No. Import. Okay. So yeah, if we successfully encode the value, then we run we basically send it via the transport. This on success thing will return the correct shape. Otherwise, if we fail, we need to send a defect, which again, I'm just littering my code base with to-dos. And now we're appropriately getting an error here because the empty... Wow. 1 second. The empty string is not assignable to one of our RPC methods, right? So if I change this to be like initialize, then it would be happy, I think. Maybe not. Oh yeah, because the result is of an unknown type, so that's also going to make it unhappy. But but again, we can fix a lot of this. The point was to get to this point where we could at least have the structure set up. And we know that we're appropriately getting requests and responses because we can, run the MCP inspector and see that we can initialize the server, do the capability negotiation, the version negotiation, and everything. And then I actually forgot to show the last piece, which is the layer I'm creating in order to run this. So, this is unknown. Oh, right, because okay. So this client RPC is 2-layer. If I extract this, it might be easier to see. Here. Client RPC handlers. Let me provide that handlers. So right now, the MCP server, because it's making use of the client RPCs, these things, right? The things that dictate what messages we can receive and then respond to from the client. It is going to, this make constructor is going to depend on having handlers in the environment for each one of those messages. And we also need an MCP transport. But we don't again, usually the user is the one for an RPC server implementation. The user is the one that's setting all this stuff up. But we have a static protocol here that we're dealing with. So we want to set up default handlers for all of these things ourselves. In the future, we can see if we can make these overridable. I think they're already overridable just by providing a different implementation in the environment, but it would be nice if we provide a little bit of a better API over the top of that. But anyways, because the constructor for the MCP server requires the handlers, we provide them here, and then the handlers in turn depend on, the types are not going to be correct here yet because I haven't implemented all the rest of the message types here. But if we did, we could probably do that really quick. But I don't really want to. If we did, we'd have a type in the environment here. Instead of being unknown, it would be, it would require the MCP server implementation and the server options because those are things we yield here. So, from a user perspective, the way it would look, usage, you would create your MCP server by doing something like, we're in the module, so I don't have to do this, but it'd be like MCP server dot layer, right? And you would basically call it the same way that you call the official SDK. Name, version, pass in capabilities, any other options you want. And then you would provide a transport. In this case, we're providing the standard IO transport, and you can override which standard in and out stream you want to use. And then you would just launch that layer to run the server. like the streamable HTTP will likely require a few other layers, but the idea is that usage would look something like this. And then you could yield the MCP server tag in your program if you needed to use it elsewhere on the server. So if you were like, I don't know, doing other things on the server and needed access to the MCP server, you could just yield it. But the implementation of the handlers right now that we have looks like this. Ping just returns literally an empty response. Initialize grabs the protocol version that the client sends, which is any right now because I'm casting it to any. Let's just do this. Let's just do this so we can have proper types. Notifications canceled. That count die message not implemented. And then I need to know what the other notification types are. Progress. There's a bunch of these. So it's like notification, resources, updated. Prompts. Tools. Message. And roots. Oops. Not on. Roots. So, and then I think we also have initialized. Oh, it's down there. Let's just do this. Okay, so I think that's all the notifications, and then we got to do the requests. So RPC.make. Notifications. And for any of you educated on the MCP server spec, you'll note that I've intentionally omitted the ability of the MCP server to send requests as well, which is to me is the most interesting / weirdest part about this spec, is that with the client and server, the client and server can both send requests and receive responses. So it's kind of interesting. I find it a little strange, but and they can also send notifications to one another. Like that part, I think is interesting, but I the whole spec is just a little strange to me. But seems to work well. So who am I to judge? I think it's interesting, even if it is a little weird. So let's keep going. I just want to get the types checking here. Resources, read, resources, templates list. We already did the resource list changed. Subscribe. Subscribe. Unsubscribe. Resources updated. Want to get the prompts. Prompts. List. Prompts. Get. Tools. List. I think there's a tools call. Yep, tools call. Logging, set level. sampling, create. Completion. I feel everybody out there being like, Max, you should just use AI. And I should. I really should. I just haven't. I think I have Code Companion installed here. I know Dylan uses Code Companion, I think. I just haven't figured out how to like work it into my workflow nicely enough yet. Okay. So we should now have proper types here. Yeah. So you can see now in the environment of the effect, we've got the MCP server options and the MCP server implementation. And we're generating handlers. So this layer will produce handlers for all of these different RPCs, and it will require us to provide server options in the server implementation. Again, I'm not entirely sure whether or not these are going to stay like separated or I'm going to put them together. I don't know. The naming is also weird, but we'll figure all of that out at a later point in time. The point now is to try to get this protocol into a good spot. So we've got our requests, we've got our notifications, and now if we look at this layer, it should, it's going to produce everything that the server needs. So it's going to produce an MCP server options, an MCP server implementation, and the MCP server itself. And it requires a transport. And then when we use that layer, we can actually just plug in whatever transport we want to use. So it's kind of similar, it's kind of similar to the official SDK in some respects. You can plug in whatever transport you want. And I think we're already going to have the ability to allow users to override handlers for each RPC. I just got to think about like what that looks like from a usage perspective. And the idea also will be that, effect, we have this very nice AI toolkit thing. If you look at the docs, tool use. So under the hood, creating tools is very, very similar to the RPC API. Like I think we're sort of kind of standardizing around this type of like thing. Maybe not, standardizing is not the right word, but like we're all converging around a similar API. Tim was kind of the first person to put something like this together. And I think for a lot of things, it fits very nicely. So you can create a tool. In this case, we're creating a get dad joke tool that our AI model can use with some parameters. And once you've got a toolkit, which is literally just a group of tools, similar to like a group of RPCs, you can create a group of tools. The idea would be you could literally just pass the toolkit into the RPC server constructor, the MCP server constructor. So the layer down here where we pass capabilities in, you could pass like a toolkit in. And then this server would automatically have the ability to use said tools, right? So you could call those tools and whatnot. So we're trying to get to that point. And then maybe we'll develop like similar APIs where you can have like kits of prompts and resources and, whatever else. But I think the first use case we really want to tackle is, since we already have an API for tools, it would be really cool to have that integration built into the MCP server natively. If that makes sense. Also, I know that my stream needs music and things like that, but I haven't put any time into like doing any of that stuff yet. So I will, but because I kind of want to stream a little bit more. I think showing like some of this development is maybe interesting to some folks. So, all right, let's see if we can figure out this issue that we're dealing with here with the fact that we're not propagating enough information into the response. I think an easy, maybe not easy, but like I think a nice way to do this could be, since the schemas are going to be per request anyways, right? Hang on. Get schemas per RPC. Here. Client.schemas.get. Where do we set this? So client.schemas.set here. It almost feels wrong to like call this like schemas. It should be like request meta or something. But we can rename that at a later point. So in here, when we get the schemas, maybe we could also like pass in the method. Or better yet, client.schemas.set. You could do something like because this metadata is going to be per request anyways. The idea being that we don't actually need to do this. To be clear, like what we probably should be doing, instead of regenerating these schemas per request, we should just have this exported from the MCP schema module, which is eventually what I will do. But again, like a lot of this code was copied from the RPC server implementation we already have. So I just wanted to get to the point where we could run something. Maybe now is the good time to do that though. So the reason why this type of code exists in the RPC server side of things is once again because we don't have control over the protocol that the user sets up in the RPC server implementation. So if we actually look at like the code is a little bit more involved here, but if we look at this, make no serialization. Where are we? Here we go. This main server loop. We have no control over the like schemas for a given RPC. From the user perspective. So what we do is when a request comes in, we attempt to get the schemas for that RPC. And what get schemas does is it looks up the RPC in a weak map. And if the schemas were not found, we construct all the schemas. So we do like the dance of setting up a decode function, an encode chunk function, an encode exit. We grab the context for that request. And then we set that in the schemas cache and return it. But in reality, for our MCP server implementation, the only real pieces of information that we need are the context for handler and the method. The rest of these things we could set up like from the MCP schema module because we control the protocol, right? So, but in RPC, we obviously don't. So like this is an optimization to make sure that we're not reconstructing these decoders every single time. Like there's no need to do that. We can do it once per request. And then if the RPC in question gets sent again, it'll just reuse the schemas that have already been set up for that RPC. And if you guys are curious, like how this looks in a little bit more of an evolved form, the RPC module like that Tim worked on is fantastic. I mean, it is fantastic. It's got a whole bunch of different protocols set up for working with WebSockets, for working with HTTP servers, for working with workers. If you want to see an example of like RPC working with a web server, a worker, our content layer series towards the end, the last few episodes, we set up workers to do the document parsing and whatnot. And we used RPC with a worker protocol backing them to do that. But anyways, I think the RPC module, this like third iteration that Tim's gone through is fantastic. It also backs effect cluster and I think workflows as well. So really great API. Like Tim did a fantastic job at this. Let's see. So I think what we can do here is we could probably just refactor the thing on the clients. So you type client. Instead of making this schemas, we can just make this like a metadata type where for a given RPC, we just grab the context for that RPC and the method. And the rest of these like encoders and decoders, we can just define in the MCP schema module. All right. Let's see if we can get to the point where we've got the method propagating properly. So let's rename this client metadata. I don't think schemas is going to be the right term anymore. And we can not export. Type in client meta. We can grab the context type from here. I don't know if it's just me, but like ever since I moved from the regular NeoVim TypeScript language server or TSLS to VTSLS, my whole NeoVim feels like slower. I have to ask Dylan like if he had the same experience. Like it takes files much longer to load. Maybe I can set up the Go language server. Okay. Read-only method. And this is going to be RPC is let's just make this string. I will have to do some casting here because the RPC is actually no, we can do RPC is type client meta. And then we can do metadata cache equals any client meta basically the same exact thing we're doing above. I just don't want to like delete it or rename it. I just kind of want to do metadata. You see honey with props. We should be able to just do. Now we can copy the internals. And then we should be able to just do this method rpc.tag. Or these. Oh, oops. Meta data cache. Where am I still setting this to schemas? Okay, that was why. I renamed it globally. All right. So this should be good enough. Let's start from the transport side of things. So when we receive a request, the metadata. I wonder if this is actually request meta. I'm like very concerned with naming things properly. Yeah, this is request because I think that it makes it easier to go back to your code later and figure out what you were doing. Get request metadata cache. I don't know if anybody else feels the same way, but I promise that for the next stream also I'll have like music and stuff figured out a little bit better. Even for Tim and my stream, it probably would be nice to have like music and whatnot. Yeah, I'll ask Dylan what he does for that. Okay, so and the reason why I think request metadata is a better name here is because this is literally a map of like the request identifier to information about that request. So I think request metadata makes sense here. So let's do get request metadata. This is going to be and actually we don't need this here anymore, I don't think. Because we're going to take this decoder and move it into the schema module. So I think we can actually delete this here. And client.request metadata.set request ID. Oh no, we do need it for right here. Yeah. So um, I think we could just literally call it here. We could do wait, can we? Request metadata to cache.get RPC. Yeah. So we can do that here. We can do metadata equals get request metadata RPC. And honestly, we could just do it up here because maybe we'll need this meta in notifications or something. We can move it later as an optimization if we want to. And then this will be metadata. And then the last thing we need to do is export the static decoder from the schemas module here. So right here. I mean, the nice thing about having it on the metadata is that I don't have to extract it from the RPC group requests. Maybe we will leave it. Let's at least just leave the decode method on here. Because otherwise it's like going to be a little annoying. And it's cached per RPC anyways, so this is fine. Decode. Here we go. Metadata. Okay. Okay. And now that we've done that, we can come back up here to our server. Thank you to all the folks who have followed me, by the way. I'm sorry for not acknowledging you all. I don't have like stream notification. I basically have nothing set up for this stream that I should. So One Shield, Gratis Victory, Birmingham 13, Mob Psycho Dev, Live Lula Eterna, Wallop the Cat, Attention Core, Hideo, Rayner, Jacob Codes. By the way, Hideo, love your work on Astro and on Starlight. We use it for our doc site. It's fantastic. Thank you guys all for following me. That means a lot. So thank you very much. All right, let's get back to this. So we can fix the chunk response thingy first. Again, I really don't think we need this yet. We may or may not need it for streamable HTTP, but I feel like we don't need the chunk one yet, but whatever. Let's just RPC server. Literally just gonna take this, bring it over here. and then this. And you can see like when I'm doing the similar stuff in like the RPC land, you have to concern yourself with stream schemas versus non-stream schemas. So, and I'm pretty sure that's why Tim just defaults to schema.any here, because I don't think you'd ever be using encode chunk unless you were in a streaming scenario with RPC. So, but again, let's just leave it for now. Okay. So in our results, so result comes in here, and method we should have on the metadata. Metadata.method. Maybe we could see if result is the problem really quick. Yeah. So instead of casting the whole thing to any, let's just cast the result to any. And the reason we have to do this again is because when we encode, this becomes unknown. So, all right. Request metadata. So, metadata. And interesting thing to note here is that if we're dealing with an exit response, that means the request has successfully been handled by an RPC handler. And so at that point, we can actually delete the metadata for that request out of our little Mac. As an, again, like to prevent a memory leak from occurring. So I'm not super satisfied with this exit encoder, but we're just going to go with it for the moment. So encode exit. We're going to need RPC's module imported. I thought I already imported it. I do. So, all right. I mean, I guess it's not really request metadata. I know I'm like harping on the naming here, but again, this helps me when I revisit this code. This is actually metadata associated with an RPC, because the request metadata, like we actually delete that out of the client, but we don't delete it out of the weak map here, because the number of entries we'd have in here is fixed to the number of RPCs that we have. So we just populate this cache over time as we get the different RPC requests coming in. But once you've done this for all the RPCs, like this weak map is fixed in size to the number of RPCs. I think. I don't know. We will. Suyosh Codes, thank you very much for the follow. Now I've got it up on my screen, so I'll see it. Thank you very much for the follow. It means a lot. Okay, so here now we can do metadata.method. And this is unknown. In a failure scenario, we need to return Failure. ID number. Okay. Actually, let's. There's somewhere else where I do this. Calls, dot squash. Oh, right there, parse errors. Okay. Damn. We don't really want. Oh, that's annoying. We kind of instead of encoding the full exit here, I think what we actually want is to encode the success and failure cases separately. So yeah, let's try something. I think I need to pull it. Exit. The reason being is because, again, the encoded version of a cause, I can't squash it into like squashing a cause kind of tries to extract like the most important error from the cause. And in this case, if we have an exit, we know that the if there's a failure, it's going to be an MCP error. Otherwise, it's going to be a defect, which will end up in this branch here. So we don't like, we want to encode the success and failure branches separately. Yeah. So failure. And you can see it here in the type. Oops. So before we ever encode the cause, you can see that the cause can only ever as far as expected. For those who don't know what a cause is, by the way, a cause is how effect internally represents errors that can be either typed like expected errors or defects that could crash your program. So the expected errors show up in the type signature, as you can see here, cause of an MCP error. So MCP error is the only expected error that this effect, the only expected error that this effect should return. Basically, sorry, Siyash, I'll answer you in a moment. I missed your first message. The inside, if you look at a cause, it's essentially like a data structure that represents both expected errors. So a cause.failure, like a cause with a tag of failure would represent an expected error. A cause with a tag of defect, or I forget what we call it internally, would represent like a panic in Rust, or like basically something that should crash the program, an unexpected error, a fatal error, whatever you want to call it. There's also a parallel cause and a sequential cause. So if you have parts of your program that are executing concurrently in effect will track those concurrent failures that happened and report them to you. Or if they occurred sequentially, one after the other, as part of like an effect operation that has to occur sequentially, it'll again track that for you. And then there's also an interrupt cause. So if your program was interrupted or something like that, that'll be reported in the cause. So an exit in effect is actually an exit of the success value and then a cause of the error. So like, that's why when we're dealing with exits, we need to deal with the cause properly. But again, in this case, we should only ever hit the exit branch, unless I'm like totally mistaken and Tim just like roasts me on this on Wednesday. We should only ever hit this exit branch if our cause does not contain a defect. So what we can do here is we can add something to our metadata like encode failure, cause.squash cause. And then on success, we can do a value metadata.encode success value. And what we'll probably also need to do here is tag these so that we can then map the response appropriately. All right. So yeah, I'm doing TypeScript development for the past 2 years, thinking to do it with effect. Dylan is also one of my motivations. How should I start though? Yeah, for anybody who's like looking to get into effect or wants to start developing effect programs, I think our docs are a pretty good starting point. So just starting to read through the docs. If you're not like the docs can be pretty dense. I won't lie. We know that it's like a limitation of the documentation at the moment. If docs are not your thing, or if like you want to try to jump in a little faster, Sandro has a wonderful type1.dev, I think. Yeah, so Sandro has some good content where you can learn some stuff on effect. I know a lot of folks. I haven't personally gone through all of his tutorials and looked at them, so I can't like vouch for them in that regard. But I know a lot of folks have done, have like looked at this stuff and gotten a lot of value out of it. And then Ethan puts out some content on effect. So Ethan's got some good videos. We also have our effect YouTube channel. If you guys want, you can look at that. And then the first half of our most recent effect workshop is on YouTube now. So I led this workshop at Effect Days this year. Oh, I hope that wasn't loud for you all. Let me drop this in chat. So there's like resources out there. They're the best, most like detailed and high quality resource would be the documentation, but the documentation does not contain docs for most packages that we consider unstable. We have a few exceptions because we want to get feedback on them. For example, like the platform APIs are semi-documented here. I've also documented the AI APIs that we've developed. So most of our ecosystem packages are considered unstable. The only like package that we've declared stable at the moment is the core effect package. But even so, a lot of folks are using all of the ecosystem packages in production. Because we try not to break things if we don't have to. But yeah, for unstable packages, usually the docs would live in a README. So, for example, if you want to use like Effect CLI, I wrote some documentation, or maybe Julio wrote this documentation a while back on Effect CLI. So there's a whole bunch of like docs in here about how to use CLI. Similarly, for RPC, the docs are like in the README, as well as like the HTTP APIs are in the README. And again, the whole point of this is that for us to document unstable APIs is a on the website is a very large development burden. It's because of the API we know is going to change, then like it takes a lot of effort to document it properly. So instead, we do it in the README, and we do an abbreviated like form of docs. Like I've already had to rewrite these AI docs like, I don't know, 4 times because I've redesigned the package a few times. So yeah, basically a try-catch type of thing. Basically, a cause is like using a catch and effect, which is better than catch. Not exactly. A cause is kind of like the result of running a try-catch, almost. Like you can think of it like you run an effect program. An effect program results with an exit, and that exit contains a cause if it's a failure. So like if it's a success, then the exit is a success and it contains the value. If the exit of the program is a failure, you'll have a cause that will detail like everything. But in most cases, like you really don't need to deal with exit and cause. Like there's better APIs on top. I'm dealing with them on a library level here because I need to. But in most cases, you don't need to deal with the exit and cause unless you're doing something a tiny bit lower level. And if you're curious on that, 2 types of errors. This is a good place to start for like learning about errors, where in effect we have expected and unexpected errors. And this is kind of the building block of like what a cause is. So we have documentation on cause here. Okay. Sorry, that was a very long tangent. Okay, what were we doing? We were gonna rewrite some of this. So we need an encode success schema dot encode unknown RPC dot schema as any, because this is going to be read-only code success unknown, and we're going to have unknown parse error and never, and then uncode failure will be the same there. I think this will be nicer to deal with. Is it error scale? Error scale. Encode failure. Type all. Not exactly sure what that's about. We'll find out. All right. So we've got our API for encoding and decoding failures here, but really we want to then map this again to and this is going to be value success value. Hopefully I'm thinking about all of this RPG stuff correctly as well. Error. Again, I'll find out on Wednesday. Failure. Could also do like an either here. Regardless, I'm going to need to whatever. Why is this? Yeah. So we should now have an either. That is kind of annoying. And the reason for these gymnastics is because the TypeScript can't really narrow well. We could do the generic up here, actually. We could do this, but I'd have to specify all the generic types. I don't want to do that. So here, now we have an either. And we could probably just do either.match on left error. And do tag failure ID num. Just feels like it's going to be really repetitive. Parse. Let's just do it like we were doing it before. Either. Error is left. Right. Let's do it. You know what? Screw it. Other dot match. We're just going to do it this way. And we're going to be a tiny bit verbose. I don't think we really say much the other way. Error. All right. Results. First. Okay. Method are incompatible. What? Ping is not assignable to tools list. Okay. Clearly. I think actually, server results. Okay. I think that we've thought the type system enough. We know that the response is going to be in the correct format if it passes these schema checks. The only thing we need to do here is actually, I think it's already handled here. Yeah. So what I was going to say is the only thing we need to do is handle the parse error that could occur if whatever we're passing in here doesn't conform to whatever. Let's call this unencoded. Unsuccess is fine. But we actually are going to handle it in here eventually. We're going to yeah. Then we're basically going to send some. So the MCP spec does have where is it? Specification. It has a spec for errors. Responses. So there are specific errors you can send. I think it's detailed somewhere in here. Architecture, maybe? I don't know where they go over it, but there are some like very specific errors you can send, and then there's like a more generic MCP error that you can send. So MCP error and so this like error spec for the JSON RPC error is like normal. You can send an error code, a message, and potential data along with the error. But you can maybe it's the JSON RPC spec that has the specific error types. Let's double check. Overview, JSON RPC. Yes, it is. So JSON RPC has like some well-known codes that you can send. It's the same structure, like the same code message data structure, but there are like some very well-known error codes that you can use. So anyway, we try to support those by just providing constructors for those specific cases. So if we look at like MCP schema, internal error. So you'll see there's like this more generic MCP error class that just has code message data. But then there's the specific cases. So parse error, invalid request, method not found, invalid params, and internal error. And these use schema.tag to define the code. And what schema.tag does is it creates a property signature for the schema that has a default value of whatever you pass in. So this way, if I want to create like a invalid request one, you'll see the code is optional because it defaults to 3200. So I only need to pass the message and the optional data to these specific constructors. Whereas if I were to use the MCP error one, I'd have to pass a code. It's not optional. So schema.tag can be useful for stuff like this. But anyways, we're not dealing with errors quite yet. So let's keep going. Defects we'll deal with in a moment. Let's actually put a to-do there. Do I have a to-do? Yes, I do. All right. We don't use this yet. This. Okay. I think, by the way, is my font like way too small for all you guys? Or is it readable? So it'll be good to know for future streams. So let's see if we can run this now. In theory, nothing should have changed. We should still be able to run this. Connect to the server. Uh-oh. Cannot read properties of undefined reading key. Yeah, this is how because it's binding over standard out and standard in. This is how you get errors reported to you. Where did this occur? Cannot read properties of reading key. Well, let's see if the issue is so I can send messages that I can log over console.error because the standard IO protocol allows you to send logging messages over standard error if you set it up. Okay, let's find out what we broke. I mean, what did we do? Hmm. I wonder if I screwed something up in the transport. I bet I did. MCP transport. What was the change we made in here at the very beginning? I don't think this is a problem. This is fine. All right, let's see what the request looks like, maybe. Because if we're not even getting to this point, then the problem is elsewhere. Console.error requests. Interesting. RPG group 25828. Let's look in there. This request get tag. Okay, ping, initialize, complete, blah, 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 blah. Sampling, create message. Sampling. I not have a handler for that? I'll do. Oh, what is the problem? You cannot read properties on a hidden key. Okay, let's do console.error. If not RPC or not RPC.key. I think I know what the problem is. MCP schema. Point Client RPC. Yeah. So client RPCs don't have a create message thingy. So that's the problem. Little extraneous. And then there's going to be, that's going to happen multiple times. We need to go to MCP schema. Problem was I was including all requests and whatnot in here when I shouldn't be. This is just for the client RPCs. So we need to look at client RPCs and we look at this. So we've got ping, initialize, complete, ping, initialize, complete, logging set level, get prompt, list resources, read resources, subscribe and unsubscribe, list resource templates, list tools, call tools. Cool. Okay. Client notifications. Canceled, progress, initialized, and routes changed. So okay. My bad. Okay. Now we're getting messages over here. This is just debug logging, even though it looks like errors. But we can see we successfully got our initialize request and our response. Just to be clear, I do have to respond with the method or no? No. Wait, do I not need the method at all? Oh my gosh. Um. Wow. Okay. So that means that this isn't needed. Server results, server success encoded. We don't need a method. We don't need a method for failure encoded either. We need it for the notifications and the requests, but not for the results, which means that we don't need it here. Or here. Or here. Which means we might be able to do this and this. Which means use our schemas. Okay, well, Okie dokie. And we may be able to like substantially simplify the server encoding stuff. Okay. All right, let's see. Let's go into the TypeScript SDK and look at shared protocol. So it's on here. We want to send this. If we can't find the RPC, then we want to send something like this, same way the TypeScript SDK does. We want to do something like return yield send, or sorry, transport that send client ID. This is going to be an error. The error is going to be a new method not found. And we're going to do message there. Should be request method. We'll send a little bit more information than that. And this is going to be request.id. Will this only occur? This will only occur on requests. So if we can't find the RPC, if request.tag equals, because on for notifications, everything is just kind of silently ignored. Try forward. Could actually just return here. Does this need an object or is it? Oh no, we're using okay. Let's do it like this. If okay, Okay, cool. So when a transport's running, if we get a request coming in, regardless if the method is unknown, not sure if it makes sense here to remove the client. Let's see what Tim does. Probably not. But let's just see. Run. At the end of this big switch statement, sends a defect. The end of this big switch. All right. Sounds like we just leave it there. All right. What other errors can we deal with here? So if we have a parsing error on the request payload, let's see what they send in the official SDK. So they run the handler. Where do they actually do the parsing? Find. G code. Maybe this happens in the server. Server. Next. Or maybe here. Deserialized message. That's what I want. Yeah. Let's. So it must be a transport day. There we go. Deserialized message. The read message in the read buffer. Source. Server. Standard.io. Where is read message? So it calls the on-error method of the transport. So then in the server, no. Connect. Just implement protocol. It does. Oh my God. This is why I hate object-oriented programming. I mean, I don't hate it. I just hate inheritance a little bit. I think OOP has its place, but inheritance makes it very hard to figure out where stuff is coming from. Where's protocol again? Source shared protocol. Okay. this.transport.onError, then it calls this.onError. Okay. This.onError, then calls this.onError. I mean, come on. Good. Okay. So the protocol. Okay. Well, we're just not going to care. So this is going to we're going to send a client ID tag failure ID post request.id error new. This is going to be a parse error. Invalid params. That's wrong. Invalid params. Let's see if they use this error code anywhere. No, this is all authors. We don't want that. Invalid. No, let's just look at the types. Error codes. Error code dot invalid params. Cool. That's the method. Right. Data params and load. And support. Cool. So now if we send an invalid request, let's test it actually. Let's fake it and say that my server supports prompting. Actually, this will end us up in the this will end up here, I think. Not where we want. But whatever. Let's just see. Okay. Let's go to some of the other error places. What time is it? 12:15. All right, I'm gonna go for another 5 minutes, guys, and then I'm gonna probably head out to lunch. But maybe we can get like one more of these error cases implemented before we sign off. Let's take a look at. So this is probably another case where we can just send the turn transport.send client.id. And we want a tag of failure. We want that. And then we want the error to be the here, everywhere where we're using transport.send, I need to make sure that when we are sending the encoded version of this, which I don't think we're doing right now. All right, we'll figure that out the next time. We'll add a to do for ourselves. So this is going to also be a what does the spec say about errors? Response object error. Parse errors. Invalid JSON was received by the server. Invalid params, invalid method parameters. Okay, so invalid request. The JSON sent is not a valid request object. Okay, it's good to know. So the TypeScript SDK, just duplicate this and go back. Because I think they also have connection closed, request timeout, parser. I think in the protocol, there's response errors. All right. Let's leave this to next time. To do and appropriate. Failure to encode response. And then we'll add some to-dos up here to do finish error types. And then the other thing is investigate the encoded errors in transport.send. I need to make sure the errors we're sending are appropriately encoded. Okay. Cool. All right. Later, folks. Have a good rest of your day. I'll see you the next time.